Glass of punch.
Hello, everyone. Good morning.
Morning.
So we'll just wait for everyone to join us, of course. Did you guys manage to sign up for codewars.com and pass the initiation challenge? Fantastic. Yeah, I was worried because we haven't really explained methods yet. So it might have been like you just put the operator there and didn't really know what return or what the surrounding thing meant. So I was a little bit worried. But I think, like learning any language, obviously you have to learn it bit by bit. Can't just explain all the grammar and stuff. So yeah, but I'm glad. Wasn't too difficult, but maybe understanding everything that's going on. Yeah. Because it's difficult to, because obviously we can't explain everything at once, and it's good to get some practical experience before knowing what like classes are and what methods are and what return does, because before the A times B, there's that little return bit. Okay, so Yusuf can't hear. I can turn up my mic a little bit, but it might be your side because Mabel can hear me. Christopher, can you hear me? Okay. So okay, I'll just send him a chat. Sometimes it is a bit weird. Like sometimes Zoom will automatically mute your audio. I don't know why it does it, but because yeah, before the A times B, there's that word return, and because we haven't covered methods yet, that word would be just confusing. But yeah, I think with the knowledge we have of operators already, the initiation challenge was, yeah, as you say, pretty straightforward. Okay, I think it will be a common problem for having lectures on a Saturday morning that a few people will be late. So I don't know, I think we'll have to just adjust to that. But I'll start, because I did make another one of those quiz things, because I think it's quite a good way to wake up and get everyone focusing and stuff. So we can start joining that just before, while we wait for other people to arrive on the call. Is it all sorted now, Yusuf, or? Okay. Cool, that's more people. I think we're waiting for till we get to like 9 participants, 8 students. Yeah, I think that's sort of where we were last week. All right, share screen. I'll close that so it doesn't take up part of the screen. Open up the chat box so that I can still see. The other students can hear me prior. Okay, cool. So it's all sorted. Perfect. Okay, so yeah, I think you guys know the drill. Same as last week. You can visit menti.com, www.menti.com. Someone's already here. It gives you a default nickname. The nicknames it recommends are a bit weird. Like in one of my classes, everyone was just named after a pop star or something. But if you prefer being anonymous, then you can just leave your nickname as that. And yeah, the code this week is 315600. You don't need the spaces, but you can have them if you want. I'm going to copy over the code into the chat so that if you want to copy paste it instead, you can. Cool. So we'll start signing up for that while other participants join the call. I see there are 6 students here now, so that's good. And the other thing, you guys were sent that PDF on the group. Today, in the PDF, we'll probably be around page 17. So also while we wait, you can get the PDF to page 17 because that's where we'll be in the textbook now. Cool, and I'll wait until about 9:05 everyone to join the Menti meeting. So yeah, menti.com, and the code is there in the chat, 315600. And yeah, you can just leave your nickname as the default, or you can put your own. Either way is fine. And cool. I'll wait until we have like at least 6 participants, but at sort of 9:05, I want to get going so that we can continue with the lecture afterwards. Okay, yeah, so there's one more person in the chat than there is on the quiz. So we'll wait for them to join and then we'll just get started because the other people are late anyway, so they'll miss out. But yeah, I don't know, because my other students like the quiz. But yeah, if there's any part of the course that, if you have any recommendations or anything, because obviously doing the online learning thing, it is quite difficult to encourage sort of participation and all of this kind of thing. So we're always open to hearing more ideas. Okay, I think we can get started. I don't know if the other person isn't joining. We'll give like another 20 seconds or so. Okay, let's get started. You can also join mid-quiz, by the way. You can join whenever you like. Given the array numbers equals 1, 2, 3, 4, 5, how would you access the number 3? So how would we access the third item in the array, which is the number 3? Nice. Okay, cool. Glad that one didn't catch most people out. So yeah, the trick to remember is that we start counting indexes at 0. So the number 1 is at numbers at position 0. The number 2 is at numbers at position 1. And the number 3 is at numbers at position 2, etc. So we start counting at 0. So everything's like 1 back from where you might have expected it to be. In like a normal counting system. So they call this an ordered system of counting, for those of you who are interested. So yeah, next question. Given int x equals 6 plus 4 times 4 divided by 2 minus 1, what value will X contain after execution? That's not the greatest question to start your Saturday morning with, some maths. But yeah, so what this testing is whether you remember how C# does maths. And you can just type a number.
Multiplication. 8 minus 1. 8 minus 1 is 8 minus 1 is 7. 7 plus 6 is 7. 8, 10, 13.
Yeah, correct. Okay, so let's see. Yeah. So yeah, the key thing to remember here was there was two ways you could have approached this, right? You could have said 6 plus, so the wrong way would have been to say 6 plus 4, which is 10, times 4, which is 40, divided by 2, which is 20, minus 1, which is 19. Okay, so I'm glad no one fell for that way, which is good. But so yeah, the key thing to remember here was that C# does know BODMAS. So this was just to cement that idea. We start with multiplication and division. So 4 times 4 divided by 2 is 8. Or you could have done 4 divided by 2 times 4 is 8. Then you can do this plus 6 or the minus 1, whatever order you like, pretty much. But as long as multiplication and division come before addition and subtraction is the key thing to remember. Okay. Awesome. Another similar question. Given int x equals 12 mod 5, what value will x contain after execution?
5, 10, 2.
Ooh, you gave it away.
I did?
Yeah. Well, because I don't know. I mean, other people, but yeah. I mean, that's good. If you.
Oh, I didn't.
No. Don't worry about it.
I thought I was unmuted.
The bigger thing is knowing why, right? Okay, cool. So everyone got it. That's great. So yeah, the key thing is you just say 12 divided by 5. What's the remainder? And you'll be good on that. So yeah, the correct answer was 2. Glad all of you guys got it. So this was obviously just testing whether you remember what the percentage sign, or what we say mod or modulo, represents in C#. And actually programming languages generally, pretty much every programming language you encounter will have that idea. Questions get a little easier now, I think, or less thinking. You need to make a multi-way branching decision. It should be easy to read. Which of the following C# statements should you use? Okay, cool. I see everyone's voted. Oh, wow, you all got it. That's interesting. I was expecting at least one person to pick like case or if, but yeah, switch is correct. We call it a switch statement. A lot of people get confused because we use like the case statements and the word break and the word default inside the switch statements, if you guys remember. And so sometimes that catches people out, but yeah, the overall structure is called a switch statement. I'm glad you guys all know that. And the if statements will just make a sort of yes or no thing. You could put more if statements inside the else portion of an if statement and make a multi-way branching decision that way. But the key reason why the answer isn't that is because it says it should be easy to read. So the switch statement is basically a way to do that in a way that's easy to read. So yeah, that's why it's not if. So yeah, good work. I'm glad everyone's comfortable with last week's content. That's good. And last question, you are writing a C# program that needs to manipulate a number whose value may include a decimal. Which data type should you use? So this is just us thinking back to the first lecture, actually. checking if we remember the data types. Yeah, correct. Ooh, I see a 6th person joined the quiz. That's cool. Oh, interesting. I didn't expect people to pick long. Okay, yeah. So so you knew it wasn't ints, right? Because ints don't have decimal places. So remember, long doesn't have decimal places either. Long is just for really, really long numbers. Short is just for really short integers. So short can hold between minus 32,000 and positive 32,000. Int can hold between minus 2.1 billion and 2.1 billion. Long can hold things greater than 2.1 billion, up to like 9, what did we find? 9.3, was it sestillion? Something like that. But like gigantic numbers, basically, inside numbers. But doubles can hold decimal points. The other thing that can hold decimal points are called floats, but doubles have more precision than floats. Okay, so that was the last question. We'll now see the leaderboard. So basically just testing who has the fastest reaction time, because I think most people got a lot right. So yeah, congratulations to Frosty. You got a lot. I imagine Dr. Centipede joined on the last question. That's our one joiner from who was late. But yeah, awesome stuff, guys. I think you guys did everyone did pretty well on the quiz. It seems like a lot of the questions that even I didn't expect you to get, you did. So yeah, that's good. Shows that last week wasn't in vain. So yeah, I think we can continue. We are recording. Let me just double check. Cool, we are, so I'll be able to upload everything to YouTube. And awesome. With that, let's continue. So we're still on this sort of introductory revision lecture, but we should finish it off today with pretty much, I would say, one of the harder concepts that you'll need to be introduced to. So just to remind you guys, we've covered this idea of arrays, right? So how to store, there was even a question about them inside the quiz, of how to store large amounts of data, right? So more than one data point, things that you might think we have to hold in multiple variables, we can actually just all throw into an array. So there were some examples here at the top, like a list of numbers. So yeah, I just wanted to remind you guys that existed. And the other thing I want to remind you of is this idea of an if statement, right? So we can make a specific decision. We can check whether or not something is true or false, essentially. So we can, Blessing, I hear some background noise. I'm muting the mic. So we can make these sort of true or false decisions. So you give it a condition like num must be equal to 6. So equals, if you guys recall, is how we ask whether something is equal to something. Or you could ask like num must be greater than 6. And in this way, we can make specific decisions. Okay. So cool. I wanted to remind you of that structure and how we write it. We put the word if, some brackets, and then curly brackets, right? So if the condition is true, then the thing inside the curly brackets is done. And the reason why I'm reminding you of this is because many statements in C# use the same structure. We'll have some word, like an English word, followed by normal brackets with a condition, and then some curly brackets to denote a block of code that must be executed. Okay, and this will come up again and again and again. This is like the standard way that actually most programming languages will frame things. Okay, so with you guys being reminded of that, we can enter into a very powerful idea in programming called repetition. So they are called repetition structures. There are 4 repetition structures we'll be covering in this course. I'll tell you their names now. You're not going to know what they mean yet, but we're obviously going to go through it. They are the while loop, the do while loop, the for loop, and the for each loop. Okay, so we're going to start with the while loop because it's where the textbook starts, and it probably is the easiest way to start because it looks a lot like an if statement. And yeah, so you can see this on page 17 of the PDF that you guys were sent in case you want to follow along. All right, so the while loop. I think the best way to approach this at first is for me to just show you a while loop and to go through step by step what the computer would do with the little code block that we're going to have on the screen. Okay, so how I'm going to do this, I've set up this sort of little example here. Okay, so in the top left, we have some code, which I think I'm going to copy into RexTester so you will be able to see what it looks like in actual C#. But yeah, on the top left, we have a bit of code here. On the right, we have like a terminal, which is basically where the computer will print things out to. And in the bottom left, you wouldn't actually see this when running the code inside RexTester or Visual Studio or whatever you're programming in, but this is sort of just a representation of what's in the computer's memory. Okay, so like a simple representation of what the computer is thinking about. All right, and basically we'll go through line by line so that you can see there's multiple lines of code here. We're going to go through line by line and see exactly what the computer is going to do. I'm going to go ahead and copy this code into RexTester. So just type it out in RexTester so you could see where it will be and what it will look like in that frame. And then we'll come back here and go through it step by step. Okay, so yeah, let me just do that quickly. So this code would occur inside our method, our main method. And cool, I'm just gonna make it full screen so maybe you guys can see more easily, zoom in a little bit. And basically it'll go, so it's int iterator, don't worry, or iterator if you like. Don't worry if you don't know what that word means yet, we'll see in a bit. Okay, int iterator equals 0. Then we type the word while, and you'll see, I'm gonna put out the structure first. So we'll have normal brackets and then curly brackets. So if you remember what an if statement looks like, it's the word if, followed by some normal brackets and then some curly brackets, right? So this is similar. It's just the word while instead of the word if, okay? We put some condition here. So the condition we have on the slides is iterator less than 3. So I'm going to say iterator less than 3. Okay, so that's our variable that we have here. And you can see it's currently set to 0. So you can imagine in an if statement, this statement would evaluate to true, right? 0 is less than 3. Right? An iterator is just a placeholder for 0. So 0 is less than 3, that would be true initially. Okay, so then the next part of the code is to say console.writeLine. And we're just going to print out iterator, okay, which is 0. So you can imagine if I put this in an if statement, it would just print out 0, right? But we don't know what a while loop is going to do yet. We haven't yet experimented with that. And then I'm going to say iterator equals, okay, so you remember what the equals operator does? Takes whatever we put on the right and saves it in the thing on the left, okay? And what am I going to put on the right? I'm going to put iterator plus 1. Okay, iterator plus 1. So, cool. So that's what the code would look like in RexTester or in any sort of place where you're going to be programming. We call these development environments, but wherever you're programming, this is what it would look like in actual C#. But we're going to jump over back to the slide and go through the main body of this code line by line and see exactly what the computer is going to be doing. And hopefully that'll help us understand what the while loop is doing. Okay, so just to go over what we already know. So this first line, int iterator equals 0, that is creating a variable. The variable's name is iterator, its type is int, and its initial value is 0. We're setting the value, we're initializing the value to 0. Okay, so its initial value is 0. Okay, this is while we don't yet know necessarily what that is doing. But iterator less than 3, that's just saying while the variable here is less than 3, this will be true. So 0 is less than 3, 1 is less than 3, 2 is less than 3, 3 is not less than 3, right? So it'll be true, 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 false. Console.writeLine iterator, all that's going to do is print whatever iterator's value is to the screen. So you guys will see that this will print here when we go through the code. And then iterator equals iterator plus 1. That's going to evaluate the statements on the right. So iterator plus 1. So whatever iterator's value is, initially 0, 0 plus 1 is 1, of course. And then it's going to save that into the thing on the left, okay, which is iterator. All right. So that's just updating iterator's value, adding 1 to iterator each time. Okay, but let's go through what this will do line by line. Okay, so you can see that a red box just appeared around int iterator equals 0. And so that's going to keep happening. The red box is like which line we are currently focusing on. Okay, so we're focusing on that first line, int iterator equals 0. And you can see what changed. Memory was initially empty, right? But as soon as we highlight that line, we've got now in memory that iterator equals 0. Okay, so iterator is 0 currently. All right, so we can continue. So we're finished with that line. That's what that line does. Creates a variable called iterator and sets its value to 0. Okay, we then come to this word while. And what that does is it says, okay, similar to an if statement, it asks the question, is iterator less than 3? Okay, and I'm sure any of you guys can answer that question, right? We go to the computer's memory. Iterator is 0, right? So it replaces iterator with 0, 0 less than 3, that is true. So the while loop goes, okay, I am going to run the code that is between the two curly brackets that are a part of my statements. Okay, so these curly brackets are what the while loop is concerned about. And so because this is true, it's going to go inside and run these commands. So it says console.writeLine iterator, and you guys will notice when we run that line, when we run this console.writeLine iterator, it prints out 0 to the screen. Okay, so we've now got 0. Because why did it print out 0? Well, it's printing out iterator, right? And we can see that iterator's value is 0. So it printed out 0 to the screen. Console.writeLine iterator, iterator is a placeholder for 0, so 0 is on the screen. We're finished running that line, so we go to the next line. Iterator equals iterator plus 1. Okay, so what did that do? Iterator was initially 0 when we got to this line. So it said 0 plus 1. It then saved that in iterator, and you can go and check memory. Iterator is now 1, right? As soon as we run that line, iterator became 1. Okay. So an if statement would stop there, right? But the word while, what it does is it says, okay, I'm going to run the code inside the curly brackets. And when I get to the end of it, I'm going to jump back to the first line. So you'll see we have finished all the code inside the curly brackets. So we're at the final curly bracket. And we jump back to the beginning of the while loop, right? So it has a similar meaning to the English word while, right? So it's saying, while this is true, do this. Okay. So we say while iterator less than 3 again, and we evaluate the condition. So we say, what is iterator's value? Iterator's value is 1. 1 is less than 3, that's true. Okay, so we go into the curly brackets because the statement is true. We say console.writeLine iterator, iterator's value is 1, so you can see that prints out 1 to the screen. And when we run the next line, it's going to say iterator, which is 1, plus 1, which is 2. And then it's going to save that into iterator. So you'll see when I go to the next line, iterator's value updates to 2. Okay, and then it's a while loop. So we're going to go back to the beginning. While iterator less than 3. So we check iterator is now 2. So it's the iterator as a placeholder here, 2 less than 3. That statement is true, right? So that's true. So we're going to go into the curly brackets again. Console.writeLine iterator, iterator's value is 2. So it prints out 2 to the screen. So we've now got 0, 1, 2. And then we go to the next line. Iterator equals iterator plus 1. So that updates iterator's value to 3, right? Initially it was 2. So this said iterator plus 1, iterator's value is 2 here. So it goes 2 plus 1, and then saves that in the thing on the left. So when we run this line, iterator's value is 3. And then we jump again, back to the beginning of the while loop, and we evaluate the condition again. But you can see, guys, what's different this time. So we say while iterator is less than 3, we go to memory, we get iterator's value, 3 less than 3, that is false. That is now a false statement. And so we're done. The while loop stops. Okay, because it's now a false statement. So that is the while loop. And you can see why this would be called a repetition structure, right? Because it's repeating this body of code while its condition is true. So while this condition is true, do this, and it'll continually do it. You can imagine if I didn't have iterator equals iterator plus 1, this code would never stop, right? It would just keep going. It'll just print out 0, 0, 0, 0, 0, 0, 0, and it would never stop until I told it to or Rex tester broke. Okay, so it'll keep going until it broke. All right, so that is a while loop. Cool, so we can confirm we have the code over here in Rex tester. So I'm gonna make it not full screen so that we can see what it outputs, zoom out a little bit. And I'm gonna scroll down and click run it, all right? And what do we expect? We expect this to print out 0, 1, 2, 0, 1, 2. So when I run that, prints out. So it's just calculating, obviously. So then it goes 0, 1, 2. See that? Cool, so that works. And you can imagine now like how you could repeat more, right? By making the condition less strict. So if I said, instead of just printing out while iterator is less than 3, because obviously 0, 1, 2 are the positive numbers less than 3, and we're starting at 0. So instead of doing that, I could say while iterator is less than 5. And you can see that it prints out 0, 1, 2, 3, 4. Pretty predictable. I could say while iterator is less than 100. And this is going to print out 0 to 99. And you can see I scroll down and it prints out to 99 and then it stops. And you could go crazy with this, right? While iterator is less than 1,000. And that is going to print out to 999. Okay. And so this can repeat as much as we want. Okay. So that's the power of repetition structures. It allows us to do a specific thing over and over and over and over again and define like a clear place to stop. Okay. So I think if you've never been exposed to this concept, it might seem a little bit confusing. Hopefully it's been explained in a way that gets you to understand. But yeah, that is repetition structures. It's obviously a very powerful thing, and you'll see that there's a lot of places where this would be used. Basically everywhere in programming where you need to repeat something, which is usually what we use programming for, right? There's usually some mundane task that a human can do. But if we explain to a computer how to do that task, it can just like automate that process, right? And it can just repeat and repeat and repeat. And it'll do it much faster than any person can, right? So you can see that by changing the condition, we can change how it outputs. We could also change where the while loop starts, right? So currently we're starting at 0, but if I started at 3, now you would see that it would start, instead of starting at 0 and going to 19, it's going to start at 3 and it'll go to 19. So you see 3, 4, 5, 6, 7. So you can change where the while loop starts by changing iterator's initial value. You could also go up by more than 1. So let's go back to starting at 0. And you can see currently we go 0, 1, 2, 3, 4, 5, because we're saying iterator equals iterator plus 1. But we could say like iterator equals iterator plus 2, right? So we'll still start at 0, but we're going to skip over 1. We're going to skip over 3 and basically just print out all the even numbers, if you think about it. So it goes 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. You can imagine that I could also change the condition that is being applied. So currently we're saying while it's less than 20, I could say while it's less than or equal to 20. So you can see currently it stops at 18 because 20 is not less than 20, right? 20 is equal to 20. So if I say iterator less than or equal to 20, then it will also run for 20. So you can picture, I can now go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and also 20, okay? Because 20 is less than or equal to. So the condition would be true on that last step. So there's lots of things I could change about the loop. I can change about how large its steps are. So I can step in 1s or 2s or 3s. You can do it however you want, right? 4s. So this will go 4, 8, 12, 16, 0, 4, 8, 12, 16, 20. So you can change the steps. You can change where it starts. You can change where it ends. There's a lot of ways to alter the loop. Okay. So that is a while loop. As we see the other repetition structures, we will gain more familiarity with how the logic is working. But yeah, for now, that's the while loop. So usually we would maybe go through a bit more examples and I'd ask you some questions. Obviously we will be doing that in quizzes and the like. But for now, I think a useful thing would more to just be to go on to the next repetition structure, see how they change, and yeah, so how the different repetition structures work, and then maybe focus more on going through a few different examples. And I'll also recommend some katas to you guys on codewars that will allow you to practice these ideas more. Okay, so that's the while loop. Hopefully no one's too sort of intimidated or anything. There is quite a lot to think about when creating a loop, right? Like as we were saying, where it starts, where it stops, and what the step size is, okay? Or how much we increment the iterator by, okay? Oh, and by the way, for those of you who are wondering about why we call this iterator, in general, in programming, it would just be called I. So you'll just say int I equals 0, and I is for like, well, there's a bit of an argument, but you could see I as standing for iterator. But the reason we call it that is because each time the while loop runs, so you see the first time it runs, it goes 0 and then adds 1, and then it goes 1 and then adds 1, and then it goes 2 and then adds 1. Each one of those steps, or each one of those times it executes the code inside the curly brackets, we call that an iteration of the loop. So that is a iteration. And so the thing that controls how many times we iterate is called an iterator, if that makes sense. Okay, so yeah, it's just what it's called. Awesome. So let's go on to the next repetition structure. That's the while loop. We will be seeing many while loops and many loops in general. So don't worry, you're not gonna be missing it for too long. Okay, so the next one is called a do while loop. Okay, it is very similar to a while loop, almost so similar that it's weird that we even have a do while loop and a while loop. Like they're very similar, but there is a subtle difference, one subtle difference. So what I'm gonna do is I'll tell you the difference first. Okay, so if you read through what's going on here, so we say int iterator equals 0, we have the word do. Remember on the while loop, we have the word while and then a condition and then the curly brackets. Here we have the word do, then we have the curly brackets defining the code. Okay, same code inside the do while loop. We haven't changed much. It's just a do while loop now instead of a while loop. And then at the end, we have the word while with the condition. Okay. If you just look at the structure, you can see that all that has changed is that the while and the condition are after the curly brackets instead of being before them, right? And that is basically the whole difference. But like in a logical way, what this is saying is that the condition is tested at the end of the iteration, okay? So when we come originally to the do, we just immediately run the code. We don't check the condition, and then we check the condition and we jump back to the beginning. And then we run the code and then we check the condition and jump back to the beginning. This doesn't make much of a difference. It's just in a very specific case where this is different. And so we're going to demonstrate that in code instead of like thinking about it too much in this theoretical way, because it would just be confusing. and seeing it in code, it really is quite a simple idea. What I want you guys to remember is if you understand the while loop, you will understand the do while loop. The difference really is silly. It's like trivial. So cool. What I'm going to do is literally copy paste this code. So we have this code in Rex Tester defining that while loop that we saw in the previous page. Okay, so I'm going to make it 3 again and just less than and iterating by 1. Okay, so as it was originally before all of our little changes to where it stops and where it starts. So it's just to keep it simple. Okay, I'm literally just going to copy paste that code. So Control C, Control V, so that the code is just below it. Right. So I've now got 2 while loops, and you can imagine this is just going to print out 0, 1, 2, and then we do set iterator to 0 again. That's important. If we didn't, then it wouldn't run, right? So we run int iterator. Oh, it won't allow me to create it twice. Sorry. So I'm going to just backspace that int away because we already create the variable iterator, and so creating it again is going to confuse Rex Tester and C#. So now you can see that this goes 0, 1, 2, 0, 1, 2. Yeah, so just remember that you have to remove the second int because you can't create, actually an interesting thing to see, right? You can't create a variable twice. Okay, so we created int iterator and we set it to 0. Okay, when we get to this line, we can reset iterator to 0 by just saying iterator equals 0. But if you say int iterator, it's going to think that you're trying to create a new variable named iterator. And it'll say, no, no, the name iterator is already taken. So you must just use the variable. You don't have to recreate it. Okay. But cool, we've now got 2 while loops here. All right. And you can see that they're both doing the exact same thing. So it goes 0, 1, 2, 0, 1, 2. Just to get the idea across, I am going to put an empty line between them. So how I'm going to do that is I'm going to run console.writeLine. Okay, but I'm going to print out nothing. Okay, so you see I give it nothing. It prints out nothing, but all that'll do is print a blank space between them. So it goes 0, 1, 2. That's what the first loop is doing. Then it prints out that blank space. We reset iterator to 0, and we have the exact same while loop running again. So it goes 0, 1, 2, 0, 1, 2. And what we're going to do here is just see the difference between a while loop and a do while loop by editing this second loop. Okay. So let's continue with that. Basically, I'm going to just, okay, zoom in a little bit so that you guys can see clearly. I'm going to edit the second while loop to just be a do while loop. And that's quite easy to do. Okay. So what we need to do is backspace the while at the beginning and just replace it with the word do. Okay, do. And then we go to the end to this next, and you can see Rex Tester highlights it for me. We go to the end of this sort of curly bracket section here, and we just type the word while. Okay. And I'm going to put the exact same condition that we have there. So it'll be iterator less than 3. And because this is now the end, we do have to put, like you can end on a curly bracket like we do here, but because this is now the end, we have to put a little semicolon there as well. Okay. So all I've done is changed this while loop to a do while loop over here. It has the same condition, The only difference is that now it's do while instead of while. Okay. And so for now, we're just going to run this and see what happens. So I'm going to minimize that. I'm going to scroll down a little bit so that we can see what it prints out. Originally, it printed out 0, 1, 2, 0, 1, 2. When I run it now, it prints out 0, 1, 2, 0, 1, 2. So you might go, well, what's the difference, right? It's just doing the exact same thing that it did previously. Okay. So we're going to look at the code and just try to visualize what would be different. Okay. But guys, trust me, if you think you understand the difference, you probably do, because it really is, it's this silly. Okay, it is this silly. So in the while loop, we have the condition at the beginning, okay? So when we start, we go int iterator equals 0, okay? So we have our iterator set to 0. We say while 0 is less than 3, that is a true statement, and then we run the code. And we went through line by line what this does, and it runs for 0, it adds 1, it runs for 2. It runs for 1 because 1 is less than 3. It adds 1, it runs for 2 because 2 is less than 3. It adds 1, and then we get to 3 less than 3, and so it stops. Okay. We then print out our empty line, and we set iterators to 0 again, and then we're running the do while loop. Now, what the do while loop does, it arrives at the word do. Now, remember, previously we said we arrived at the word while, and we checked, is iterator less than 3? Is 0 less than 3? That's true. Okay. But with the do while loop, we arrive at the do, and we don't check anything. Okay. There's no condition here. We haven't seen a condition yet. We just see the word do. So we arrive at the word do, and we just run the code inside the curly brackets. So we just print out iterator, which is 0 currently, okay, because we set it to 0. We say iterator equals iterator plus 1. So iterator is now 1. And then we come to the word while, and we check, is iterator less than 3? So we go 1 less than 3. That is true. Okay. If the statement is true, we jump back to the word do. Okay. And then we repeat. And so this actually does pretty much the exact same thing as a while loop. The only difference is that what if your condition is false on the first execution? Okay. So basically, the do while loop, as we saw, the first time we ran the code inside the curly brackets, we had not checked the condition. With the while loop, we check the condition every single time, including the first time, right? The first time we arrived at the while loop, we immediately checked if iterator was less than 3. Whereas with the do while loop, the first time we arrive at the word do, we didn't check anything. We just ran the code. Okay. So to see where this is different, what I'm going to do is change iterator to 3 in both cases. So int iterator equals 3. And on this line, after our new line, I'm going to say iterator equals 3. So let's visualize what would happen here and see if we're visualizing things correctly. So we say int iterator equals 3. All right. So we set iterator to 3. With the while loop, we come here and we say while iterator less than 3. So iterator's value is 3. So 3 less than 3, that is false. Okay. Because it's false, we don't ever run this. We don't run this. We just skip. We print out the new line. We set iterator to 3. Okay. We don't even have to do that in this case because iterator is still 3 because we haven't done anything. But just to make sure that the loops are separate. Okay. So we set iterator to 3. We say, let's check what happens with the do while loop now. With the do while loop, we arrive here and we say do. Okay, so the computer just says do. So it just does it. It doesn't check anything. It just prints out iterator, which is 3. So this time it'll print out 3. It'll add 1 to iterator. So it'll say iterator equals iterator plus 1. Iterator is 3. So 3 plus 1 is 4. And that's saved into iterator. So we've got 4. And then we check the while loop and it goes, while 4 is less than 3. 4 is not less than 3. That's false. So we move on, right? We stop. We are not running the do while loop anymore after that. Okay. So if our interpretation is correct, the first while loop will not do anything. The second while loop will print out iterator and add 1 to it. We won't see that it adds 1 to iterator, obviously, because that's hidden in the computer's memory, but it is doing that. Okay. So when I run this, we expect it to just print out 3. And you see it prints out 3. Okay. So literally, the only difference, and don't get too worried about it, because it really is, a lot of people get a bit worried because it seems so simple, but that really is the difference. And it's only in this case. So the do while loop and the while loop will, in general, produce very similar outcomes. The only time it's different is when the statement is false, when the condition is false, the first time the while loop runs. then, or is supposed to run. The while loop will not run. Okay, so you can see iterator was set to 3 initially. So the condition was immediately false. So the while loop did nothing. Whereas with the do while loop, iterator was initially set to 3. So the condition at the beginning is false, technically. But the do while loop doesn't check the condition the first time it runs. Okay, so the do while loop does not check the condition the first time it runs. There are other ways of saying it, other ways of phrasing it. Why is it not for? Why are you saying iterate? Why did it not print out for? Is that what you're asking, Mabel? Why didn't it print out for? Okay, so remember that the code still runs in order. Okay, so I'll show you this, Mabel. So just because this is quite an interesting idea. So iterator was initially set to 3, right? We come to the do. We run this code in order. So it says console.writeLine iterator. So it prints out 3, okay? Because iterator is 3 here. When it gets to this line, iterator is 3. Then it says iterator equals iterator plus 1. So it does become 4. Iterator does become 4, right? Because we did add 1 to it. And then when we check the condition, it says 4 less than 3, which is false. And so it stops. In order to show you that iterator really does become 4, what I'm going to do is instead of printing out iterator first, I'm going to backspace that. Okay? So I'm going to remove that line of code. And I'm going to add 1 to iterator. And then I will print it out. So I'm going to say console.writeLine iterator. So the only difference is that I'm now adding 1 and then printing out. Okay? And you'll see that this time, it prints out 4. Okay. So the code, remember that you're still going through it line by line by line, all right? So the reason it was printing out 3 instead of 4 is because the printing was happening before the addition. But now the addition happens before the printing. Okay? Like you can see in the previous while loop. Yeah, cool, awesome. So remember, things are still always happening in order. Just because it's repeating doesn't mean that it'll like skip a line or go back to lines. The only thing where we do go back is with the actual while itself, right? So while will jump back to do if the condition is true. And with the while loop, when it gets to the end, like of this curly bracket section, it jumps back to while. And it'll do that while ever the condition is true. Okay. So yeah, that's just the distinction. Okay, but things still happen in order. Cool. So that is the while and the do while loop. Again, don't get too hung up. It might seem like, wow, this is so silly. Like, why would you even have this? But yeah, it's just laziness, right? There are specific times where you want the condition to be checked every single time. So you only want to do it if it's true, and then you want to repeat it, and you want to constantly repeat. But there are other times where you want something to run at least once, okay? And then if something is true, you want it to repeat, okay? So for example, I can try to give you maybe like a real world example where this difference might be relevant. Actually, yeah, for the distinction, so why we might have both. Picture you have a robot standing at the edge of a cliff. Okay, there is a robot standing at the edge of the cliff. Maybe I can actually draw this. Actually, no, it won't. Actually, yeah, I'll draw it. I need to get a mouse quickly because my handwriting is. The drawing's going to be bad even with a mouse, but with a touchpad it will just be terrible. So I'm just going to grab a mouse. I have one right here. Okay, I don't have a mouse pad though. Let me just plug this in. Okay, so where might this be different? And then after I explain this difference, we'll take a quick break. Okay, so, all right, here I am. Actually, I must just disable the pointer. All right, so I need a blank page actually. So I'm just gonna go back to the beginning here. Okay, So we'll have two robots, and one will be working with the while loop and one will be working with the do while loop. Okay. So this will be the while robot, and we're just going to mark it as a W. Again, I did say my handwriting would be terrible, so don't laugh about it. Drawing with a mouse is horrible. Okay, so we're at the end of the cliff. This little robot is programmed with a while loop. Okay. Okay, it's a stickman robot. Okay, and then we're going to have another robot at the edge of another cliff. Strange example, I know. I could give examples about like how these would be working on like a website, but I feel like that's actually less explanatory. Okay, so this robot, I'm just going to put DW. So DW. This robot is programmed with a do while loop. Okay, and the part of it that we are programming is the walking. Okay, we're programming walking. So our condition is when you're not at the edge of a cliff. Okay, so like whatever we could say, like the cliff is like at, we would give it like a little position. So this is at like 6 and this is at like 6. Okay, and we're trying to check if our robot is going to take a step. Okay, so our condition is like maybe while you're at position less than 6. All right. So while you're not at the edge, of a cliff. Okay. The while loop robot, before it walks, it will check it's starting from no motion. Okay. So its initial position is 6, and we're just checking if it's going to take one step, and it would obviously continue walking afterwards if the condition was true. So this robot will ask, okay, my initial position is 6. I'm about to see if I'm going to take a step or not. So it'll say while my position is less than 6. Okay, its position is currently 6, right? So it's not going to take a step because it can immediately see it's programmed with the while loop. So it checks the condition. It says 6 less than 6, and it goes, nope, I'm not taking a step. I'm at the edge of the cliff. The do while robot says, okay, it just takes a step. So it says do, and it's what the thing inside the curly brackets is to take a step. And so it just steps off the cliff and falls to its doom. Okay. And then after it's taken the step, it checks is 6 is, because it's now at position 7, right? Because it's taken a step. Okay. So it's now at position 7. It checks is 7 less than 6. And it goes, oh, wait, that's false. I'm off the cliff. 7 is not less than 6. Okay. So that's the difference of where you might use a while loop versus where you might use a do while loop. When it's taking its first step, the while loop will always check. It checks every single time before it runs. Whereas the do while loop will run once. It will always take the first step. It'll always run once, and then it checks. Okay, so that's the only difference. And you could give another example of where you might want to do while loop instead of a while loop, when you want something to be done at least once, and then it must check. So like regardless of the condition, you want it done at least once. Okay. Awesome. Okay, so hopefully that was a bit of an illustrative example. If you understood it before the example, then that's fine too. Okay, so yeah, the only difference, if a do while loop, you'll use when you want something to be done at least once. Okay, at least once. Awesome. I'm glad it wasn't a well-drawn diagram, but hopefully it was an illustrative one. Okay, sorry. Awesome. Okay, I think, yeah, let's take a 10-minute break. So we'll come back at 10:05. And then we will learn about the for loop, which is the next structure that we'll use. Also, probably the most important repetition structure, the next one we cover. Oh, sorry, I should send that to everyone. I'm just going to say 10:05. So yeah, we'll come back at 10:05. The for loop is probably the most important repetition structure we'll learn. So yeah, be ready when you come back. I'm going to go get a glass of water, I think. I'll be back now. Feel free to post any questions in the chat or wherever, and I'll answer them either during the break or after we start again. Okay, but yeah, see you guys just now. Cool, I'm back. Yeah, if anyone has any questions, you can also say them through the mic now and I'll answer them immediately. But otherwise, yeah, we're only starting again at 10:05, so no hurry. Yeah, 100%. You could send it on WhatsApp. I think, is probably the easiest. And yeah, actually, it might be illustrative as well. Like while we're on the break, I could type it out here as well, and we can go through. Because yeah, whatever mistake you made is probably quite would be quite a common one for a person to make while programming their first one. Because yeah, it's quite difficult for me to tell. So yeah, definitely, if you could send me a screenshot on WhatsApp, or if you can just save the error, I might be able to figure out what's wrong. But I can leave mine here as well, so like over there. So you could also do it sort of comparatively. Ah, cool, thanks. Okay, so let's see. Public static void iterator equals 0. Ooh. Ah, okay, it looks like, yeah, okay, this is an interesting one. Okay, so yeah, there's two things. So I'll make mine look like what yours is. So you remove this. Okay, so you don't have the second semicolon. So you can see it sort of breaks, like when you highlight it, the one that's highlighted, I mean, not semicolon, sorry, the bracket. When you highlight it, you'll see it's sort of broken. This first namespace highlight will highlight in red because it doesn't have a partner. And the other thing is that you have a semicolon on this line, so that's a problem too. So yeah, the first thing, remove that semicolon. The first, if it's a while loop, so the do while loop, because the while is at the end, you do need that semicolon. But for a while loop, because it starts and it's followed by a curly bracket, you do not need it. The other tip I'll give, and this is a good one to learn generally, like it's generally good practice, is when you program. So when I type the word while, you'll notice I don't type like a single bracket and then say like iterator less than 3 or like I less than 3 and then close the bracket. You'll never see me do this. When I type while, I'll go open bracket. Okay, so open the normal bracket, immediately close it. And then I'll say, like maybe go to the, if I'll open up a curly bracket. So I'll go like curly bracket, and I won't type things now. I'll immediately close it. And so what this does is it forces you to keep brackets. Whenever you open a bracket, immediately close it, and then go back into the brackets and add whatever needs to be there. So that's just generally good practice. And so that forces you, because one of the biggest problems is keeping your brackets aligned. Got hair in my mouth. Okay, so then we say iterator equals iterator plus 1. Okay, so yeah, actually, yeah, two really, yeah, for someone new, those were, so yeah, so always, as soon as you open a bracket, close it, and yeah, no semicolon after this. So you had a semicolon there, that shouldn't be there, and make sure you always close your brackets. Yeah, if I look at this, yeah, those are the only two problems. Everything else is fine. Great. Cool, yeah, no problem. Okay, we're getting started again soon. Yeah, cool, we can go. Sorry, I am being pretty, I guess, strict about time, but it's, yeah, we do have a lot to cover in sort of however long we have. So Important parts of a loop. Cool. So I did say we would go on to learn about the for loop, which is probably the most important repetition structure, the most frequently used repetition structure. It's one that you'll find in every single programming language. So what you're learning here doesn't just apply to C#. The for loop is everywhere. It's basically like the bread and butter of any programmer. But before we go into the for loop, I want us to just learn or think about what the important parts of a loop are. Okay. Now you might say, you might be wondering like, why are we doing this exercise? But you'll see how it feeds into our learning of a for loop in a bit. Okay. So I want you guys to actually help me with this because I don't want to be the one to point it out. I'll tell you this much. There are 3 important parts to a loop. So if you look at what I've got on the screen now, I've got a little excerpt of code with the while loop that we've seen. And I've got a little excerpt of code with the do while loop that we've seen, right? Each one you'll notice has 1, 2, 3, 4, 5 lines, or around that. Did I count the blank space? Okay, 7 lines rather. And this one has 1, 2, 3, 4, 5, 6, 7 lines as well. Okay. We have discussed these like specifically when learning about the while loop. But what I want you guys to tell me is to look at this sort of while loop structure. And I'll say that there are 3 important lines. So this is line 1, this is line 2, line 3, line 4, line 5, line 6, and line 7. There are 3 very important lines out of these 7 outlining the logic of the loop, I'll say. So I would like for you guys to tell me at least like one of the 3 lines, but ideally we'll go through all of them, that you think are important. Okay, and hopefully we'll knock down all 3. So yeah, can you guys help me with that? Which of these lines is important to the logic of our loop? There's 3 of them. So it's pretty easy maybe for you. Like if you say a line, it'll probably be correct. The method. So are you saying, so rather give me a line number. So if you want to say line 1, then just say 1, 2, 3. Actually, maybe I can, because I don't know if you guys can see my pointer. So 1 is where int iterator equals 0. And then like 2 is that blank line. 3 is the line with while on it. I assume so someone says, okay, line 3, cool. So someone says this line with the while on it is important. And yeah, that's correct. So that's one of the 3 important lines. Can someone give me another?
What line?
Did you say line 1?
Line 1, yeah.
Okay, I think I heard line 1. Yeah, your mic was very quiet, but yeah, please do use the mic if you want. That's cool. So yeah, line 1, that is an important one. And there is one more that is important to the logic of the loop. So we have 1, 3, and it's basically, yeah, choose between these lines. So this is 5 is console.writeLine. Is that the important one to the logic of the loop, or is 6 the important one? What do we think, guys? 5 or 6? Which one's more important to the logic of the loop?
I think line 7 is important because while goes exactly at the end of the bracket. So it doesn't have its own line.
This is true, yeah. But so yeah, basically you can see like the new line as pretty irrelevant, like C# won't see it. So yeah, you could picture the loop ending where the semicolon is hypothetically. But yeah, that is a fair point. That is a fair point. But I think for the logic of the loop, we can probably agree that 6 is more important than 5, right? Because we could do anything we want on line 5. We happen to be printing out here, but whatever's on line 5 is not really going to affect how many times the loop runs. So yeah, both. So we're most said 6, and so yeah, 6 is the more important one. So but yeah, as you point out, if you left out line 7, it would break. If you left out this line after the while with just the curly brackets, it would break. So in a way, all the lines are important in that sense. But to the logic of the loop, line 1, 3, and 6 are important. And you can see another reason why you could see they're important is because they exist in the do-while loop as well, in a way. It's just that in the do-while loop, line 1 is still line 1, okay? Line 6 is still line 6, but instead of line 3 being on line 3, it's actually on line 7, where the condition is, okay? But why am I emphasizing these lines? Well, these lines are so important that they actually have names, okay? They're very important to like a theoretical understanding of loops. So I'm highlighting them now. So int iterator equals 0, we identified that as important. The condition, right? Iterator less than 3, iterator less than 3. You can see it exists in both loops. That is important. That's line 3 and the one we were looking at, okay? That's a very important part of the logic of the loop. And we can see highlighted in blue now, that this line is also very important to the logic of the loop. These are so important that they have names, okay? The thing highlighted in red, int iterator equals 0. That is called the loop initialization, the loop initialization. Why is it called that? Initialization, you can see the root of the word is initial. So it's the initial place of the loop, right? Where the loop starts, our initial starting point. Okay, so loop initialization. The bit highlighted in green is called the loop condition, the loop condition. Okay, and the bit highlighted in blue is called the loop increment, the loop increment. Okay, so you can see like, why is it called the condition? Well, you can see it is a condition, right? It's true or false. And it's defining where the loop stops, okay? The blue, called the loop increment, is defining the step size, if you like how do we get from where the loop is initialized, so where we start, to the condition, to where we stop. And the loop increments is sort of what defines that, like how we get from the start to the end. Okay, so these three parts, they're so important, like as you can see, they have names. And they're very important to the logic of a loop, any loop. Like all of them technically need a stopping criteria, a place to start, and a way to get from the beginning to the end. So the start to the stopping criteria. So all loops have these three things. In some cases, they might be hidden from you. Okay, they might just be hidden from you, but they always are there. Okay. They might be hidden, but they're there. Okay, so the reason I wanted to cover this before we learn about the for loop is because understanding these three parts of a loop is essential to understanding the structure of a for loop and like why they are the way they are. Okay. Cool. So with that understood, we have these three criteria that are important to the understanding of a loop. We can move on to the for loop. Okay, so in order to illustrate this, on the left, we have a while loop. This while loop we have seen before, okay? The only difference here is instead of writing int iterator equals 0, I said int I equals 0. So I'm just using the letter I instead of writing out iterator, just because it's easier, right? So I'm just using the letter I. So int I equals 0, and then we say while I less than 3, and then console.writeLine I, and then I equals I plus 1. This is identical to the while loop that we were working with on the previous slides. The only thing is that the variable's name has changed from iterator to I, because it's easier to type. Okay, oh, and actually we should ideally do the same thing on the left. So hold on, I'm just gonna, oh, all right, sorry, cool, that's fine. Where did the chat disappear to? Okay, so as you'll see, so don't worry too much. I don't know why it didn't. Okay, it's a bit annoying. Okay, so this should be console.writeLine I, but you'll see it's a bit strange. So that the basic idea. So ignore the console.writeLine for now. The basic idea is the thing highlighted in red green, blue on the left here. So our initializer, our condition, and our increment. In the for loop, you can see I've put, so we have the word for, the same way we have the word while, right? We have our normal brackets and we have our curly brackets. So the structure is identical, right? The structure is basically identical. The difference is that in the normal brackets, the for loop requires us to specify the initialization point, so int I equals 0, the condition, so I less than 3, and the increments, separated by like semicolon. So you can see initialization, semicolon, condition, semicolon, increments. Okay. All of those things in the for loop go in the exact same place. They're all inside the normal brackets. So you can see on our while loop, they're a bit all over the place, right? The initialization is somewhere above the while loop. The condition is where you would expect it to be, right? It's inside the while loop, inside those normal brackets. And then the initialization, the increments is somewhere inside the while loop, right? So it's like a bit all over the place. Whereas in the for loop, all of these things go in the loop, in the sort of declaration, inside the statements, inside the normal brackets. Okay, so initialization, condition, increments. So what would that look like? Taking the thing on the left, all right? So int I equals 0, while I less than 3, taking this exact while loop and translating it into a for loop, you'll get the thing on the right. Okay, so these two things do the exact same thing, right? So this is another important thing to understand. Anything you can do with a for loop, you can do with a while loop, okay? So the for loop is not essential in that way. Anything you can do with a for loop, you can do with the while loop. The difference is that the for loop makes it more readable, okay? Everything's basically where you would expect it to be. Or like you can look in one place, on a for loop, you can look at one place and you can see the initialization point, the condition, and the increments all in one place, okay? There's this other little trick to note that's often used with for loops, is that instead of saying I equals I plus 1, like we do here, I equals I plus 1, you can just say I plus plus, okay? Those two things mean the same thing. We'll see that in code now if you're not super comfortable with that. And there are some other little things that we have to explore about that as well, because the questions do come up in the MTA exams. So we will actually be spending some time on that before we go too far with for loops. Okay. Cool, but that is actually the basics of a for loop. If you understand the while loop and what those different parts are doing, then you understand the for loop. This for loop on the right will do exactly the same thing as the while loop on the left, the while loop that we've been playing with. Okay, cool. Now, before we continue with for loops too much, I do want to just take some time to understand so I'm going to remove all of this, okay? I do want to spend some time because we didn't cover it while we were going through the different operators because it would have been a bit weird. So we are just going to cover it now. Okay. So we've seen a bunch of operators, right? So sorry to be jumping around a bit, but I think it makes sense to cover it this way because these are where these operators are actually used. So if you recall, we've covered all these operators. You guys were tested on them this morning and yeah, there was no problem. So you guys pretty much all got these questions. So we had, our basic sort of maths operators, plus, minus, times, and division. And we have the mod operator, okay, which was a bit of a special thing, but still okay. We also had the equal sign, right, to assign things. So it takes the thing on the right and saves it on the thing on the left. We also had like a bunch of weird ones, right, like greater than, less than or equal to, and these sort of return true or false, right? They're a way for us to ask questions. What I want you to notice, the reason I'm writing out all of these operators that we know, is because what I want you to notice is we have a thing on the left, okay? We have whatever operator you want. So like this could be equals to, less than, greater than, So we have all the operators, and then we have a thing on the right. And each operator follows this kind of template, and the operator just changes what's done, right? There's something on the left, something on the right, and the operator will just do something with the thing on the left and the thing on the right, okay? Not too, it's a pretty simple template that we're working with here, okay? However, there are another group of operators which we glossed over. They are quite simple. It's basically just a trick, a shortcut, but this is the good way of explaining it. And you can see that these operators have something on the left and something on the right. They have two things. There are another group of operators that only have one thing. Okay? So it doesn't have something on the left and on the right. They have something on the left or on the right. Okay? Or on the right. So these operators are called unary. Unary is just a fancy way of saying like one, I think. It's like, you know, binary has two, unary has one, basically. So unary operators, it's just one. And one of these is plus plus. Another one is like minus minus. Another one is like plus equals. There are quite a few, but to start, we're just going to explain plus plus because it's a pretty simple thing to understand. Okay. So the plus plus operator is a unary operator. So we're used to operators having something on the left and something on the right. This operator will have something on the left or on the right, but like only one, exclusive or. Okay, it can't have something on the left and on the right. Something on the left or on the right. It can be on either side, but there can only be one thing. Okay, so how does that work? I'll show you now. So we can say int I equals 0. And this we're used to from our loops. So trust me, this is kind of related to what we've been doing. But we do, I think it's a common thing with learning like anything, you know, you do have to, there's a bunch of related topics is the problem that we have to deal with when learning programming. Okay, so we have this int I equals 0, right? We're used to seeing this. And what we want to do is add 1, like every time we run our while loop, we sort of add 1 to this variable I, right? We say like I equals I plus 1. You're used to seeing this. Okay, so I is initially 0. Then we run this line. And what I'll show you, so I'm going to print it out here. So I'll say console.write. Okay, console.write is very similar to console.writeLine, but writeLine will make a new line. Okay, so writeLine will print out what you give it and then put a new line afterwards. Console.write will just print out what you give it. But they're basically the same. You don't have to know the difference. Okay, so you can see this just prints out 1. So why did it print out 1? Hopefully we all get this by now. So we created a variable. Its initial value was 0. We say I equals I plus 1. So I was initially 0. 0 plus 1 is 1. That's saved into the thing on the left. And then we printed out I, which was 1. Okay. Now, programmers are very lazy. So sorry, we had to go through all of this. But the basic idea behind this unary operator is that programmers are very lazy. So once upon a time, I suppose, a programmer noticed that currently on this line, we are saying I equals I, okay? And then we say plus 1. The point is we're writing out I twice here. And we're using an equals sign, which is like, it's a lot of characters. This is a lot of typing. And so a programmer once decided that instead of writing all of this, they would create a special operator, plus plus, okay, plus plus. And this does exactly this, pretty much exactly the same thing. There's a subtle difference that we'll go through just now, but it's pretty much identical. So in order to see, I'm going to run this again, and you can see it's just printed out 1. So all plus plus does is add 1 to the variable that is next to. Okay, it adds 1 to it. Remember, it is adding 1 and assigning. Okay, so it's doing the job of a plus sign and an equal sign. Okay, to the variable you give it. And you might go, wow, this is very lazy. It is. And yeah, it's basically just saving you typing 2 extra characters. And unfortunately, it's used so frequently that we do actually have to learn about it. So yeah, but yeah, so and now you can imagine you can do this with minus minus as well. So I minus minus, all that's going to do is print out -1. Okay, so I was initially 0, and this is essentially doing the same thing as me saying, instead of saying I minus minus, I could have said I equals I minus 1. So that is 0 minus 1, and that makes it -1, of course. Okay, so you could also say I minus minus. We're going to focus on I plus plus though, because we don't want to get too carried away. Okay, so yeah, we've got this. All right, I plus plus. Now, all right, so int I equals 0. So what is the difference? And there is a difference. There is actually a difference. So what we're going to do in order to show the difference between I equals I plus 1 and I plus plus is instead of printing out I after we type I plus plus, I'm going to print out I plus plus like this. Okay. Okay, I'm also going to print it out on the next line because this is probably the best way of doing it. Ooh, actually, this will teach us 2 things. So you'll see that now it prints out like 0, 1. But if I say right line instead of just right, it'll give us a nice space between the 0 and the 1. But what's going on here? Okay, so the difference between saying I equals I plus 1 and just I plus plus, sorry about that, and just I plus plus is that I plus plus will also return the value. Okay? So what do we mean by return? So you can understand, weird idea to explain, but you can sort of understand that when we say I equals I plus 1, the computer isn't giving us anything, right? The computer is working in its own memory. What it's doing on this line is sort of hidden from us, right? It goes, we say I equals I plus 1, and the computer just does it, and we just trust that the computer did it. It's not giving us anything back. When we say I plus plus, the computer doesn't just add 1 to I. It also shows us, it gives it to us. It goes, yeah, and you can check, here's I. Okay, it gives us I, right? So another way of explaining it, when we say console.writeLine I, what we're doing is we're asking the computer to actually go to where it's stored I in memory and to give us the value that it's stored there, right? And when we say I plus plus, it's the same. We still ask the computer to go to that place in memory and give us what's stored there. And then it runs plus plus and it adds 1 to it. Okay, so you can see when I go console.writeLine I plus plus, it prints out 0 because it goes and fetches I from memory, right? Goes and fetches I from memory, and I's value is 0, so that's correct. Then it adds 1 to it. And so when I print out I on the next line, you can see it prints out 1. Okay, because it did add 1 to I. It added 1 to I. Okay, so hopefully we understand. I know we're spending a lot of time on plus plus, but it just is it's a difficult concept to get across because it's a bit it relies on some intuition about how computers work, I guess. Cool. I did tell you that a variable can be on the left or the right of the plus plus, right? So we are going to see what happens. What happens when we put it on the right? Okay. So this time, the computer gets to the plus plus and it goes, okay, I'm going to add 1 to whatever memory location I'm given. It's not given 1 on the left, right? So it looks on the right and it finds I. So it adds 1 to that memory location. And the difference is now that it adds 1 and then it gives us to us. So now it'll print out 1, 1. Okay, 1, 1. See that? It's a subtle thing. It's just some laziness. So don't blame me. I didn't invent C#, but most programming languages do have these little tricks, these unary operators. it's some laziness that so we can easily add 1 to a variable and then return it, or return the variable and then add 1 to it. Okay, so, but you can just read it in order. So don't get too concerned because there is a sort of easy way of understanding it. So when I say I++, the computer gets here, it sees I, so it gives us I, which is 0 initially. It then sees the plus plus, so it adds 1 to I. Okay, so you can literally read it in order. I came first, so it returned 0, and then it added 1. But when we do it the other way, so we say plus plus I, so now it sees the plus plus first, so it adds 1, and then it returns I. So you can see that prints out 1. Okay, super subtle difference, but you can be asked about this. So we did need to spend some time on it, because it's not like just a thing we can gloss over, obviously. Okay. So yeah, sorry, this very weird niche shortcut had to take up like 15 minutes of the lesson, but it was important to get across. But in general, what we can see here is that so I++ in general is just used as a shortcut for saying I equals I plus 1. That's what's relevant here. These are equivalent. Okay, so it just adds 1 to the variable. Okay, in most cases, except in this little niche that we discussed, but we'll see some quizzes about it, so you'll be able to get it. Okay, cool. So yeah, sorry about that little digression. Now what I'm going to do is sort of jump us back to our while loop. If I can get that far back, I can't. That's unfortunate. So we'll have to type out that little bit again. Okay. So I'm going to write out a for loop, a while loop quick, and we're going to translate that while loop into a for loop. So what we say is int I equals 0. Okay. So that's our initialization of our while loop. We say while I less than 3. So that's the condition of our while loop. Okay, we say console.writeLine I, and we could do it before or after the plus plus, right? How about we do it after this time? So I'm going to say console.writeLine I, and before I print out, I'm going to add 1. So I'm going to say I. Oh wait, no, then it won't be equivalent. So let's just do it normally. Yeah, sorry about that. So I'll say I equals I plus 1. So this is exactly what we've seen before. Okay, we've seen this while loop. It's the one we've been working with the whole lesson. Okay, so while I is less than 3, and we say I equals I plus 1. Okay, and we also print out I just before we add 1 to it. All right. So let's translate this into a for loop. How would this work? So I'm going to comment out the while loop so that it's not, so it's there, but it's not being read as code. So this is just being read as some text. You can see that Rex Tester highlights it in green for us. So it's just reading that as nothing. It's not code. Okay, so we've got our comment there. What I want to do now is translate the while loop we have here into a for loop. Okay, so how we do that? We'll say, instead of the word while, we have the word for. So I'll say for. I'm going to open up the normal brackets and immediately close them, and open up the curly brackets and immediately close them. And we've got our structure. It looks a lot like a while, right? Instead, if we wanted it a while loop, we would just put while there, but we're using the word for here. Okay. So what does the for expect from us? Inside these normal brackets, it expects us to give it the initialization, semicolon, the condition, semicolon, the increments. Okay, that's what the for loop expects from us. All right. So, and we know where these are, right? This in our while loop is our initialization. Okay. This in our while loop is our condition. And this is our increments, right? Okay. So, literally what I'm going to do is just type these things where they're needed in the for loop. You could even copy them. I'm not going to copy them because it's bad to do it that way. It's better to practice by typing it out. So we'll say int I equals 0, where the initialization is expected. Exactly how we've seen. The condition, I'm going to say I less than 3, right? So the condition is I less than 3. So it stops when our variable I has a value of 3. Okay. And the increment is I equals I plus 1. Now I could say I equals I plus 1. That would be totally fine. Okay, that will work. It will work. But the standard way of doing it in for loops and in general, actually, like here in our while loop, usually you wouldn't see a programmer say I equals I plus 1. They would say I plus plus. Okay, just because it's a nice little shortcut. And same goes here. So I equals I plus 1. We would instead say I plus plus. Okay, so that just adds 1 to I. That's all it does. And we just went through sort of all of the little weird things about these little shortcuts that they created. Okay, and so that is the for loop. The only thing we have to add now is what is it actually going to do? So inside the body is where we put what the for loop must do, right? So inside the curly brackets. Okay, and all our for loop is going to do is say console.writeLine I. Okay, and so this for loop is identical to the while loop that we created. It has the same initialization, the same condition, and the same increments, and it prints out I at each increment, okay? Or at each iteration, sorry. Each iteration, it prints out I, console.writeLine I. Okay. So, cool. Let's run it to make sure I'm not lying to you. I'm going to remove the comments, so it's just taking up less of the screen, and we've got our for loop right there. Okay. So, making it not full screen, I run it, and we see it goes 0, 1, 2, which is exactly what our while loop did, right? And remember what we said. Anything you can do with the for loop, you can do with the while loop, okay? The only thing the for loop really offers is this nicer way of writing the structure, okay? Everything goes in one contained place, which is very convenient. And in general, when you're working with loops like this, you will be using a for loop, okay? But all the same things apply, right? I can change where the loop starts. I can change where the loop ends. I can change how much it goes up by. So instead of saying I plus plus, I could say I equals I plus 2, for example, to go up by 2 each increment. So all the same things apply. Okay, all the same things apply. And we can go through all of the different ways these things work. Now, there are some tricks that you could be asked about, okay, which we should cover in detail. Yeah, so the first one has to do with when, because the way questions are phrased about these. So one nice thing, I suppose it depends how much you like multiple choice tests, but one thing about the MTA course, at least at this level, the next level is called the MCSA. So this is like MTA, Microsoft Technology Associate, and MCSA is like Microsoft Certified Software Architect or something. But yeah, so the thing about this level is that the test is multiple choice. There's no programming. So when you're tested on for loops, what you'll be asked is sort of like, how many times will this loop run? Those sorts of questions is what you would be asked, okay? So luckily, it is pretty easy to see. It's just, you have to understand how the condition affects the result. So for example, if I give you something like this, it's pretty easy to see this loop runs 3 times, right? It goes 0, 1, 2. So how we would ask that is we would say, how many times does the loop execute? And when we say how many times does the loop execute, what we mean is how many times is the code inside these curly brackets run, okay? You could also be asked, how many times is the loop condition checked, right? So that's a different question, right? Because let me explain it. I can explain it this way. So if we jump back to our little while loop here, where we went through it line by line, right? So let's think about these two questions. There's these two questions of how many times is the loop executed and how many times is the condition checked? Okay, so we start at line 1. So this is the loop condition being checked. So the condition has been checked once. Okay, it executes. It's been checked twice, right? Because the red box is around the condition. So it's been checked twice. The loop executes. It's been checked 3 times now, right? Because the box is around the condition. So this is the 3rd time the condition has been checked. It executes. And then the condition is checked again. So the condition has been checked 4 times now. And then the loop stops. Okay. But notice that the loop only actually ran 3 times, right? It said 0, 1, 2. So the loop executed 3 times, but the condition was checked 1 extra time. Why is that? Well, we check the condition. If it's true, we run. We check the condition. If it's true, we run. We check the condition. If it's true, we run. Then we check the condition 1 more time. We see that it's false, and so we stop. So the condition is checked 1 more time than the loop actually executes. So that's one subtlety that you must be aware of when being asked questions about loops, okay? Because you have to check the condition that once extra to confirm that it's false, right? Makes sense. You have to check that condition 1 extra time. Okay, cool. So we are back to the for loop. Okay, so let's think about these questions. It's the same here, right? The condition has to be checked 1 extra time just to check that it's false. Okay, so with that subtlety understood, let's focus on loop execution. So how many times is console.writeLine executed? So we can see it's executed 3 times because it's printed out 3 things. Okay, 0, 1, 2. All right, so the loop is executed 3 times in this case. How would we get to 3? Well, you could say the end of the loop, right? 3, because it ends at while I is less than 3, minus the start of the loop, 0. Okay, so the loop is executed 3 times. Start minus end. Okay, start minus end. So that's one very easy way to check, like, how many times will the loop run? And you can imagine if I say less than 100, how many times will this loop run? Start minus end. It is going to execute 100 times. So for 0, it prints out 0, and it prints out 1 to 99. Okay, so it executed 100 times. All right. So the loop executes 100 times in this case. The start, end minus start. I don't know why I was saying start minus end. End minus start. Okay, so it ends at 100 minus 0 because it starts at 0. Okay, so end minus start, 100 minus 0. Okay, and you can see that this works in other cases as well. So if we say 3 and instead we start at 1, okay, so end is 3 minus 1, which is the start. We expect this to run 2 times, and we can see it executes twice. Okay, cool. Unfortunately, it's never that simple because there was lots of things we could change about the loop, right? So we can say we can change where it starts. So we've seen that our rule still works there. And we can change where it ends. So our rule still works there. But the other thing we can do, and you must be careful about this. So when you're asked a question about a for loop, read it very carefully. And just, you know, be careful about what sort of calculation and what sort of thing you must be thinking about. Because the other thing we can do is change the condition. So instead of stopping while I is less than 3, we could go while I is less than or equal to 3, right? And now you could see that our rule, unfortunately, would break, right? Because we would say end, which is 3, minus start, which is 0. So our little equation would say 3 times, right? But you can see that this now actually runs 4 times because it doesn't stop when I is 3. It runs that 1 extra time. So if the condition you're using is less than or equal to 3, it would instead be end minus start plus 1. Okay. So we arrive at this weird place where there are lots of different calculations you could potentially be asked to do. Okay. But probably the best way for you to learn this is instead to just actually understand how the loop works, okay? So if you want an easy way out, that will work in a lot of cases, but you have to be very careful about using any set equation because there's so many things about a loop that we can change. But probably the better way to approach these loops and these calculations is to actually understand how the loop works. Okay. So yeah. And one extra quick trick that I will just tell you guys is that it still kinds of works when we say I equals I plus 2, okay? Because you essentially just divide the answer by 2. But obviously there can be odd numbers. So this would be running by our rule end, which is 3, minus start, which is 0. Because it's I less than or equal to, we would say plus 1. So we would expect it to run 4 times, but we can see it's adding 2 each step. So we divide by 2 and the loop would run twice. But the better way to do this is to actually understand, okay? To actually understand what it's doing. But yeah, the only way, you know, unfortunately, we can't go through every possible for loop. So the only real way to do this is to really, you know, experiment and to work with for loops. But don't worry, there's plenty of time over the course. We'll be programming a lot of for loops. And so there's still time to learn this. Okay, one more thing, and then we'll go back to Code Wars. We'll quickly solve and discuss the initiation challenge a little bit. And then I'm going to recommend one extra kata that you guys could try out this week if you wanted, or next week. I think we'll give 2 weeks to try out this first kata. Okay. The last loop that we need to cover. So there were 4 repetition structures. We've covered the while loop, the do while loop, and the for loop. The last one we have to cover is one that's very special to C#. Not many languages have a for each loop. But yeah, so C# does, it's called the for each loop. And this is why I reminded you guys about our discussion of arrays. We'll probably have to revise the for each loop a little bit next week. But what's lucky for us is that it reads a bit like English, okay? It's a bit like just reading the English sentence and you'll understand what it does. So quickly, just to show you, I'm going to create an array of integers. So the array is going to be int. It's going to be called numbers or nums for short. So I'm just going to say nums. So like plural, okay, nums. That's the name of the array. And it's just going to be a list of numbers. So I'm just going to make mine 5, 6, 7, 8, 9. Okay, 5, 6, 7, 8, 9. All right. Hopefully we can see that. So what we want to do here is say, we want to use a for each loop. So for each loops are designed to work specifically for arrays. Okay, and what a for each loop will do is we can see we have a lot of items in our array, right? Here we have Ali, Josh, Maya. We might also have like 5, 6, 4, 7, 8, 9, like we have in the Rex tester at the moment. What we want to do with the for each loop is go over each one. We'll get a little quiz at the end of each section. So sorry, someone's asking if there's an assignment calendar or if we get real tests or exams. We will do mock tests at the end of each section, testing that section's knowledge specifically. There are also knowledge assessments at the end of your textbook. And once each week, I will be recommending a kata. You don't have to do the kata. I will check them and we'll discuss them in class. But really, because the test is on theoretical knowledge and because we have so little time, we have to prioritize that, but we'll still be doing these practicals on the side because obviously it's a good way to learn. So hopefully that answers your question. There isn't a calendar. No, we'll do it on a sort of weekly basis. And like how quickly we get through the sections will depend how we do the mock tests. There is only one real exam that counts for real marks. Okay, everything else is just us testing and gauging how well you guys are doing. The only exam that counts is that last one you write for your MTA certificate. Okay. Cool. But we'll discuss all of this stuff, all the testing and whatever as we move through the course. Okay, so we have an array of nums. A for each loop is just a loop that will go over each thing in the array. Okay, so how it works. literally you can just read it as English, okay? So what we'll do is exactly like a for loop. It looks quite similar. We would say for each, we'll have some normal brackets and some curly brackets. So the same structure we're used to, okay? Some normal brackets and some curly brackets, all right? How we use a for each loop is we say the type of the array that we're working with. So int, okay, in this case, for each int, then we say, we give it a name. So this, our int is called nums, all right? Nums, the array nums contains numbers, right? So each thing in the array nums, we might call a num. You could call it whatever you want. You could also call it x or whatever. You can call it whatever you like, but just to understand sort of the English phrasing of it, we could say for each int, so it's an integer, it's an array of integers, for each int, num in nums. So there's this keyword in, all right? So what this is doing is it's going to go over nums. So you can see there are 5 numbers inside our array nums. And for each one, it's going to create a variable called num. And so the first time the loop runs, num will be 5, and then it'll be 6, and then it'll be 7, and then it'll be 8, and then it'll be 9, okay? And so in order to show you that, I'm going to say console.writeLine num. Okay, and you'll see what this does. So it goes num 5, 6, 7, 8, 9. Okay, so you see it just goes over each part of our for each loop. I mean, of our array. The for each loop will just go over each bit. It'll create a little variable for each one and just print those out. Okay. Well, it won't print them out normally. Obviously, the reason it printed it out is because I put console.writeLine num. So yeah, it just created a variable called num. And at each iteration, num will just become a new thing in your list. And it can work with anything. So if you have a double and we make it 5.2, 6.1, 7.6, 8.3, and 9.4, for example. So we've now got a list of doubles. We could say for each double num in nums, and then it'll just go ahead and print out the doubles. Okay, so it can work for any data type, strings as well. You would say string word in words, for example, if you have a list of words, or string name in names, if you have a list of names. String email in emails, if you have a list of emails. And that's just how for each works. It's pretty simple. One thing I want to clarify, just before I recommend the kata that I want you guys to maybe try, will be a bit of a challenge, but the first katas that you do will always be challenging, right? Because it is learning something new. What I'm going to do here is I'm going to make every second number negative. So we have 5. Instead of 6, I'm going to make it -6. 7. Instead of 8, I'm going to make it -8. And then we're going to say 9. Okay. And I'm going to make them integers again. So int nums equals this. So they're integers. And then for each int num in nums. Okay. So you can see the only thing that's different here is it's printing out 5, -6, 7, -8, 9. Okay. Cool. I want to show you that this idea is pretty powerful still. Even though it's just printing out everything in the array, I can still use the information. So each number will be held in num. So if I could put an if statement here that says if num, so if, I'm going to put the curly brackets around the console.writeLine. Okay, something like that. I could say if num is greater than 0. For example, if num is greater than 0. So now what will it do? The for each loop will go over each thing, right? So it'll say 5. Num, the variable num will hold 5 the first time the loop runs. So it'll say if num is greater than 0. So if 5 is greater than 0, then it's going to print out 5. Okay, cool. The for each loop goes to the next thing in the list, -6. So num is now -6. It asks if -6 is greater than 0. That is false. So it won't print out. You see, last time I printed out -6, but now because we put this in this for loop, it won't print out -6 because -6 is not positive, it is negative. Okay, it's not greater than 0. Okay, and you can see 7, it will print out because num will hold 7. 7 is greater than 0, that's true. -8 is not greater than 0, that's false. So it won't print out -8, and it will print out 9. Okay, so that's how the for each loops work, how the for each works. And this will now just print out 5, 7, 9. Okay, instead of 5 -6, 7 -8, 9. So you can put it in an if statement so that you can do more powerful stuff. Okay, so this if statement was telling us if the number was positive. Now you could imagine we could like maybe add all these, we could create a little integer variable here, and we could maybe add up all the numbers. This was just me giving you a little hint. But yeah, there we go. That's the for each loop. Maybe we'll discuss it a little bit more next week. But for now, I want to jump over to Code Wars to discuss the katas quickly and all of that. So I'm currently logged into my account on Code Wars. That's what you're seeing on the screen currently. Zoom out a bit. Oh. Okay, no, so we were at 100%. I'm just going to sign out of my account quick. Okay, and I'm going to go to the sign up page. So I click sign up, and this is the home page that you guys would have seen. We click C# because we're learning about C#, and it gave you this little initiation challenge. Now, you could possibly overcomplicate this because we haven't yet learned about methods. We haven't yet learned about this word return. We haven't yet learned really about classes properly. So there's a lot here that's new, right? But the main thing, this initiation challenge was, as Mabel said at the beginning, it was quite straightforward in that you just had to know the operator for multiplication. So we just say return A times B, and all that's going to do, so all I had to do was add that little asterisk there, and then it'll work. Okay. And you can see if I click submit, it says, cool, satisfied, the testing all works. All right, as we learn more about methods and return statements and all of that kind of stuff, we will be able to understand exactly what's going on in that initiation challenge in more depth. But for now, it just shows you that the problem isn't always difficult, right? Sometimes it is literally just the straightforward approach. But understanding all the subtleties is a bit strange. Okay, so that was the initiation challenge. Hopefully most of you guys managed it, but after you solve that initiation challenge, you could create an account. I'm going to log into my account here quickly. Cool. So when you log into your kata, to your Code Wars account, it'll give you something like this, all right? This is Code Wars once you've got an account. And you can go to the side here. Initially, you're at home, and you can click on kata. Okay, kata. And kata will give you a bunch of different challenges that they recommend for you. Okay. What is quite useful is that you can filter out these challenges. So there's multiple different difficulties. There are 8Q, 7Q, down to 1Q. Okay, 1Q are very hard. Some of these, quite literally, you could write PhDs about. They are very difficult. So we're not going to be doing 1Q, of course. But like 8Q is the easiest challenges they have. Okay, so we'll start with 8Q because, you know, obviously we're still familiarizing ourselves, but they are still challenges. Okay, so you must take your time on them. They are puzzles, and you will have to think about them. Okay, so you can filter by 8Q. You can filter by the language you're interested in. So I clicked C# because we only want to see kata that are available in C#. And yeah, so you can scroll down. There's all of these challenges here. Okay. The challenge that I think really summarizes what we're learning in the course now, and one that I think is probably good for us to attempt, is called sum of positive. Sum of positive. So what happens here? So you click on sum of positive. That's the name of the kata, sum of positive. It's an 8Q kata. And it'll bring up this screen. And you can see it gives you a little task here. It says you get an array of numbers, return the sum of all the positive ones. Note, if there is nothing to sum, the sum should default to 0. Okay, makes sense. So we can click on train. and it brings you to this screen. Okay, on the left here, it's reminding you about the challenges. And over here, it gives you a little place to code. All right. So this is the kata that I want us to attempt. The way that you'll do this, so it gives you the array already. Okay, you don't have to set the value. So if we go over to Rex Tester, you can see I created an array of nums here. An array called nums. Their array is called R, ARR. They've already given you the value. You don't have to set the value. So they'll give you random arrays and they're testing you, right? So they want you to get the correct solution, all right? So they give you the array of values. It's already passed in here. So you can see it's int with the little square brackets R. Okay, so they've given you the array. Okay. They give you a comment here that says your code here. So you put the code that you write over here. Okay. And our goal here is to put an answer. Okay, so int answer equals 0. Okay, it starts at 0. And we want to go over the numbers that they have in this array. We don't see them. It must happen automatically. They're hidden from us. We want to go over all of the numbers they have in the array, which we do with a for each loop, right? I'm not going to type any more because I've given you guys a bit of a hint here. And we want to check if a number in the array is positive. And if it is, we want to say, we want to add that number to our answer integer. And at the end, we will return our answer, okay? So you'll have some kind of for each loop, okay? For each loop. Inside the for each loop, you'll have an if statement, if positive, okay? And inside the if statement, you'll have something to go, if the number is positive, we add it to answer, okay? Add it to answer. And once you've done that, you would have solved this kata, okay? So I've given you sort of the solution in comments here, but you'll have to actually convert that into code. And hopefully you could do that by next week, okay? But we'll take some time. We'll go over it next week as well in more detail, all right? So that is this kata. One more thing, I know I'm taking up too much of your time now. We are 2 minutes over time. So I'm going to leave the kata there. I'll solve it myself as well during the week. But what I want to also show you guys is this other interesting thing that they have. So if you go to the top right here and click account settings, you'll be brought to a page like this, all right? There is this tag here called clan, company, school, or organization. Mine is set to brighter futures, okay, brighter futures. And so if you must type it the exact same way I have it typed here. So capital B space capital F futures, okay, brighter futures. If you set your clan to that and scroll down and click update, then we'll automatically, like it'll automatically connect our accounts so that we'll be like friends or allies or followers on codewars. Okay, so if you could also do that by next week, then we'll be like in the same organization. So we'll be able to communicate and I'll be able to see the code that you write and you'll be able to see what I do. And, you know, we'll basically be able to see each other's progress and help each other out. Okay, so if you could do that as well. So you just click on account settings, you change your clan to brighter futures, you scroll down and click update, and then we'll be put in the same clan. Okay, cool. And so that is it for today, guys. Hope you enjoyed and learned. I know we are going quite fast. We are going quite fast, but it's not, yeah. It's the only way, unfortunately. We do have less time than we would otherwise have. So yeah, but hopefully we still have enough time to learn. Cool. So that's that for today. Cool. Thank you, everyone. Bye-bye. Bye-bye. Cheers. Cheers. Yeah, see you next week, Saturday, same time, same place. I'll try to remember to post the meeting schedule, the schedule for the meeting or the invite the day before to remind you guys. Sorry, I just posted it this morning because I had forgotten to send it the day before. Okay, cool. Cheers, everyone. I'll post the video to YouTube as usual, so you'll be able to refer back to it. If you need help on the kata, you can go back and check out the hints. Okay, cool. Bye-bye, guys.